Let's understand about the spiral model in this lecture and how does this behave or how does this work basically in an appropriate manner where we have to understand the SDLC or the life cycle approach kind of strategies. The very first thing is this 100% relates to the waterfall model, but the complex situation in this waterfall model was that they were never corrected. You cannot correct them immediately, or wherever you find corrections, you cannot correct them because they were never going back. The upstairs case was not possible. The upstairs case was not possible, and in case of upstairs case when not possible, the correction is not. In this particularly, we find a corrective unit runs side by side. Whenever you find yourself in trouble, you can correct the errors, whatever you have made in kind of application of the system. And when you move ahead, you can simply find the all articles available, all patches available, which definitely benefit your already installed system. Let's see this history. The spiral model was defined by Barry Boehm in his 1988 article. I told you as before that they are not very old, but definitely they are outcome of the problems or they are the solution in terms of the waterfall model. This model was not the first model, and definitely this came after the SDLC's very first approach of waterfall model, which were being popular. Definitely were being very much smarter or very much simpler way, but definitely we did not find them as a purpose or as a way to sort out immediately the problems whichever occur basically in this particular system. And this is spiral model. We can find when the cost and risk evaluation is important. Two things are very important. When you have to see in terms of the cost involved, or when you have to see in terms of the project cost, overall project cost, which increases suddenly and gives you high kind of cost, which suddenly makes your revenue low, then definitely you have to look into a system which can be correct. The plan implemented, the money is already spent over this waterfall model. If you simply try to find out, come back or maybe recover, it is not possible. This is not possible. This can never be. But in case of having a waterfall model substitute, we definitely go for the cost reduction cost, and definitely this cost reduction is only possible when this spiral model is going across. Because you can, side by side, always correct the plan. You can always make a beneficial arrangement for that, for medium and high risk projects. Definitely, all the projects are not that much safer, and they need to be corrected and they need to be analyzed first before they are implemented. So before implementation of all these projects, we must we must understand, like whatever we have invested or whatever we have done to that particular part, they must go in such a way so that it becomes easier that the risk involved remains the lowest. The risk involved in this remains the lowest risk. So when you talk about the lowest risk part, definitely we need to have a corrective plan first, which immediately corrects itself. If there is no comeback, then definitely it's lost. But if it can be corrected thereon, then definitely it's a strong plan. Third, users are unsure about their needs. Yes. For a beginner, for a person who's going to first install uh, any kind of SDLC or system development, he's not sure about his needs. He's not sure about his needs. So whenever he finds his needs upcoming, or whenever he finds his need to be generated immediately, that can immediately be implemented within that particular process. In case of waterfall model, well, it was not possible. You cannot improve much more things. But in this, it is quite possible that if correction is possible, if the induction is of more opportunity is possible, then definitely is a popular plan. The next thing is requirements are complex. As a system developer, I must say that no one can immediately say that how much complex this structure is going to be, or you never know how much complex this system would be later. So definitely requirements, when the complexity of the requirements is there, then definitely you fall into a situation like up to what extent you have to twist yourself, or to what extent you have to make the plan ready for the purpose of availability. Then this is a program which which is easily opening and easily transformable, or it is always an open kind of system. It is not that closed system which you cannot correct. It's an open system. Like finally, we have significant changes are expected. Whenever you feel you are not very much sure about implementing a particular program, you can always seek for a solution which makes your plan successful in terms of what? In terms of understanding its complex situation, in terms of understanding the changes. So whenever it is required to be changed, whenever it is required to make a change, definitely this program is very less complex to understand. Then there are four procedures involved. What are these four? The very first is evaluating the first prototype. We don't go as it is in terms of application. We simply go in terms of the evaluating the plan, in terms of understanding the plan or evaluating the plan. First, evaluating the prototype in terms of its strength, weaknesses, and risks. SWOT analysis. While you are going to implement a spiral model, you understand what exactly the prototype would look like. You make a blueprint. You make a blueprint, and that blueprint basically works upon a system which reads first about the strengths of that particular purchase, weakness of that particular purchase, and opportunities involved in that particular, right? Then definitely the requirements of the second prototype. First of all, you know about the SWOT analysis, and then you try to understand what exactly would be the all possible requirement when you are implementing. Like what exactly you are looking for. Through this system, what exactly you want it to do. Through this system, what kind of decisions you want to make. Through this system, what exactly you want to design. When it is clear, when it is very much possible for you, then only you define the second thing, that is the possibility of requirement. Every that possibility which defines your requirement is a part of this particular process. Third, planning and design the second prototype. Second prototype means your analysis is depends on this. First of all, you collect all the requirement, then you design over this particular requirement, how to fulfill this requirement. This also comes under this aspect of its four-fold procedure, right? First, SWOT analysis. Second is identifying the requirement. Third, working on those requirements which basically have to be defined or have to be designed on the basis of their solution. And fourth, constructing the testing and construction and testing of the second one. Whatever requirement you have designed or whatever part you have designed now, you have to go over the part of constructing that. Definitely you are building that particular module, or you are building that aspect, which makes it possible to understand that. Next, then it's the very first is working over the prototype. Let's take one by one altogether. A prototype is an early sample model or blueprint. We don't simply implement. But we examine. First of all, we try to find out the feasibility of that thing, whichever we are going to implement. And when you're going to implement, or when you are going to publish that particular plan, then definitely you have to see the blueprint. If this works or not. As your mother definitely makes some recipe to your place, and she asks you to taste this, just to find a feel of that particular aroma, taste, smell, whatever it is, then definitely it's a prototype, which makes it possible you're going in the right way or not, right? Second is what? Second, the phase. You can find here in this particular structure, there are four distributed parts. The very first is customer evaluation. Second is plan. Third is risk analysis. And fourth is user. But when we start this thing, then we start right from the very first thing in this quadrant. The first thing is plan. Everything starts with plan. Planning starts going clockwise. Then it is risk analysis. Every time you analyze or you fulfill that particular part which makes you risky, which make anything risky, right? Then definitely the third one is the engineering. The engineering means working over this particular layout. How would you sufficiently work upon this? How would you basically work upon that particular part in terms of its engineering? And third one is the customer. What exactly the customer wants? What exactly the customer's need are? Or what exactly, how do you beneficially you can give this to your customer? The very first thing is commencement. You can simply go, if you go through this, then it is the step one, the stepping. risk analysis, coming down, operational prototype, then it is benchmarking. And right from this is the last spiral which I have discussed. We always start from the very root level or the kernel level. Huh? The very pinpointed strong level is the very first internal part. Like requirements plan, life cycle plan. So first of all, you have to identify the requirement. Revolve, analyze the risk or the revolve. What kind of operation would it be employed? Look, in every quarter, the activity has been defined in that particular way. First is planning. Most of the time, you will find the planning is simply the judgmental part. Second, risk analysis, engineering, risk analysis, engineering, risk analysis, engineering. Everything is coming through the risk analysis and everything is being engineered. Keeping in view the customer evaluation. You can simply find risk analysis, prototype, engineering over the prototype, working its feasibility, going up again and again. So spiral is not moving inside. Spiral is basically opening up. As much as this opens, you can simply find the generation of the spiral moving around, moves in such a wider way that particularly that makes particular plan open or wide, and that makes particular plan to be open in such a way so that this becomes a implemented system, implemented structure of a particular system. Let's move together. Planning. The very first quarter, if you remember, the objective, alternatives, and constraints of this project are defined basically in this particular quarter. You have to identify, you have to judge basically what exactly you have to put as an internal planning part. What exactly you have to do, what exactly you are fighting for, you're working for. Second, risk analysis. Risk analysis is one more mode, but risk analysis is one more part which makes it quite possible to analyze the possibility of errors. Wherever you find the errors, you should immediately start correcting them. So the possibility of risk immediately reduces. The possibility of risk immediately surpasses. And you always come into the profitable part. The space identify the resolve of all possible risks in the project development. Third, engineering. Engineering basically the part where we work, which is analyzed and which is developed. The actual development of the project is carried out. The output of this phase is passed through the phases interactively, and in order to obtain the improvement in the same. We always go through with this particular cycle of engineering of making the things. Third thing is the last thing is customer evaluation. Finally, we fall into a situation which decides, which gives you the developed product is a passing through or is a pass out product or is a approved product. Customer in order to receive customers' command and suggestion. As we finalize our system development, we come to a situation when we are coming across or we are coming in front of the customer just to find out how much he is supporting that particular strategy or he is supporting that particular style which we have simply adopted. So this SDLC or this powerful plan ends in such a way which says that the testing part is over, or when you simply find it is a testing when the customer as a judge comes to make a statement, yes, I'm satisfied, I'm happy. That makes the program or that makes the plan or that makes this kind of SDLC spiral successful. Application, yes, if the approval is there, the customers are satisfied, the customers are happy, then definitely application is no more longer this thing. You immediately go for the part of applying that. The spiral model is used the most often in a large project because the correction is possible. Many, as you can see, many possibilities were there. For a smaller project, the concept of agile software development is becoming a viable alternative, while it is also responsible to use the spiral model in project where the business goals are unstable. Unpredictable business, unpredictable chances, unpredictable goals, everything is unpredictable. So why should you go for a system which is more hazardous? You go for a system which is more safe, which is more applicable. Advantages. Changes are always possible. I'm going fast. Allows extensive use of the prototype. Everything is coming in front of you in a blueprint first. Everything in front of you coming in a way such a way which makes this possible. Like you make a test, and then only you make it qualified for the further stage. Requirements can be captured accurately. You exactly know what exactly you have to do. You exactly know what you have to make exactly for your next step, for your purpose of organization. Third, users see the system early. We start seeing the things because the prototypes are so visible. The prototype start claiming this. The prototype start making this very much possible. Like what exactly will it look like, or what how will it work later? And early and frequent feedback from the users. Now, as soon as you finish working with the particular one spiral or one uh, clockwise movement, the output immediately comes, right? And finally, the disadvantage is the end of project may not be known socially because every time you are testing, every time you are working over the project viability, so the project does not end very fast. Next is not suitable for the small unit, as I told you. This is sometime uh, everything is so prototype, everything is so testing, everything is so tested. So definitely for a small requirement, it is not so feasible. Like it is, as I told you, it is not always for the big operation. Next thing is process is complex. Process is complex because you are not moving ahead in a systematic direction. You are always going in a prototype, testing, prototype fail, again testing, prototype pass, again testing, prototype successful, then further moving. So it is always a complexity. It is always complex to move. A spiral maybe go indefinite. A spiral means a spiral a ring kind of work. You're not sure where will this end. If further prototype is available, if the further prototype is required, the spiral again starts moving, So you're not sure from which end it will start and from where, or at which point this will end. And finally, you said it is risk assessment expertise required. You must hire the people, or the system analyst must be very much capable of understanding the risk involved in this particular way, right? Then finally we move into the thing like if you have to make a particular decision or if I have to compare the decision between the waterfall model and spiral model, both have their goods and bads. Both have their feasibilities, both have their approaches in a right manner or a wrong manner. But this program is sure shot, this spiral thing is a successful plan and this has been implemented at so many platforms, at so many corporates, like wherever the correction, where the complexity is more severe, then definitely this is the system which can be adopted as a best. Thank you.